John Dalton was born on September 6, 1766, in Eaglesfield, Cumberland, England. He died at the age of 77 on July 27, 1844, in Manchester. John Dalton was a chemist, meteorologist, and a physicist. His notable work in chemistry had to do with the atomic theory. John Gough, Dalton's mentor, was a blind philosopher and polymath, and Dalton owed much of his scientific knowledge to his teachings. Because of him, Dalton was appointed teacher of mathematics and natural philosophy at the New College, also known as Oxford, which is located in Manchester. In 1801, Dalton presented a series of papers called the Experimental Essays about the constitution of mixed gases, the pressure of steam, and other vapors at different temperatures. But the most important of all Dalton's investigations are those that have to do with the atomic theory. The 5 main points describing the atomic theory are: Number 1, elements are made of extremely small particles called atoms. Number 2, atoms of a given element are identical in size, mass, and other properties, but atoms of different elements differ in size, mass, and other properties. Number 3, atoms cannot be subdivided, created, or destroyed. Number 4, atoms of different elements combine in simple whole number ratios to form chemical compounds. Number 5, in chemical reactions, atoms are combined, separated, or rearranged. Another law that Dalton founded, the law of multiple proportions, has to do with the idea that chemical combination consists in the interaction of atoms of definite and characteristic weight. The idea of atoms arose in his mind as a purely physical concept, assisted by the assumption that combination always takes place in the simplest possible way. He thus arrived at the idea that chemical combination takes place between particles of different weights, and it was this which differentiated his theory from the historic speculations of the Greeks. This was merely an assumption derived from faith in the simplicity of nature. No evidence was then available to scientists to see how many atoms of each element combine to form compound molecules. In any case, Dalton's rule of greatest simplicity caused him to assume that the formula for water was OH instead of H2O, and ammonia was NH. Quite different from our modern understanding. In addition, the idea that all atoms of a given element are identical to their physical and chemical properties is not precisely true, as we now know that different isotopes of an element have slightly varying weights. But however, Dalton had created a theory of immense power and importance.